Welcome back for Advent of Code day 21. Today, it was another reasonable day. The first part was very trivial. We just have to encode this simple two-player game based on a 100-face dice. And so here you can see the implementation if you want. In my input, player 1 started from position 1 and player 2 started from position 3. I implemented a class to represent a dice with 100 faces that remembers how many times it has been rolled. Then I had a player that have a name, a position, and an amount of points. To take a turn, the player just rolls the dice 3 times and takes the total of the 3 results. There is a little bit of a trick in the position. As you well know, doing modular arithmetic is the easiest way to roll back to an initial value, but it will push you back to number 1. And so I'm storing a position that is actually 1 less the actual intended position of the player. In the main, we simply run the game, and until none of the two players have won, player 1 make a turn. If the player 1 haven't won, then player 2 also makes a turn. Part 2 is way more interesting, and it's about the multiverse, where every time we roll our dice with 3 faces, the universe splits in 3 different sub-universes. One of the tricky bits to do this part is to make sure that the game properly stops as soon as one player wins, because if we just roll for player 1 and we roll for player 2, we get a different number of universes output. Thanks to automatic caching, 42 is a pretty good language to do this task. I can make a report class that is just a pair of numbers storing how many times each player wins. A result is open if no player have won yet, and then I have a way to sum results that just compose the subparts. Finally, I have a state class that is our computation object for caching, and we have our 4 fields, that is the position and the score of player 1 and player 2. There was probably some very smart algorithm that could be created from these quiz, but I tried to just play simple. So I have a method to make player 1 take a turn and a method to make player 2 take a turn. Then I check if there is a direct win. That is, someone have just won in this state. And in that case, no one have to roll dice, so the universe doesn't split further, and we just return either a win for player 1 or a win for player 2. And here is our cache lazy method, where we return a report checking how many wins there are. First, we check for a direct win, and if we already have a winner, that is, the game is not open anymore, we just return the result. Otherwise, we use this range object from 1 included to 4 excluded, so from 1 to 3, the 3 valid results of our dice, and we make 3 rolls on our dice, but we actually split on all the possibilities. So the body of these first 4 is going to be executed 27 times. Then player 1 makes a turn, and if the state we go is a direct win, then we just accumulate the result from this roll into the res, the local variable. If we don't have a direct win, then player 2 can play. And so, again, 27 times we roll for B1, B2, and B3, and we get our state B by building over the state A. If state B is a direct win, that's it. We just sum it to the result. Otherwise, we do a recursive call to state B.wins. Without the cache annotation, this method will take forever to compute. But thanks to caching, we actually terminate in a reasonable amount of time. Indeed, there are not so many possible states. The position is a number from 0 to 9 for both players, so 100 cases there. And the points will always be from 0 to a little bit more than 21, because when we reach 21, the game is over. So we have probably not much more than 50,000 different state objects that we need to consider, and that will go to populate our cache. Finally, the main just creates the initial state and calls for s.wins. So, today, thanks to automatic caching in 42, day 21 was easy. And so, see you next time!